Let's construct some binary trees. Okay, let's say when the number of nodes is equal to n. So for n is equal to 1, this is the only binary tree. This is one node. Okay. Now for n is equal to 2, what you have to do, either add a left child to this or either add a right child to this. So you get these two binary trees. Okay, for n is equal to 2, you get these two binary trees. For n is equal to 3, okay, you can take any of these two trees and you can add a node to it. Okay, so if I look at this as a base tree, okay, then you can add a node, a right child to this, you can add a left child to this, you can add a right child to this. If you add a node to this node, then the height of the tree will not change, okay, because you are not adding a node to the maximum depth. And if you add left or right child to this, then the height of the tree will increase by 1 because you are adding a node to the leaf at the maximum depth. So this was my base tree. Using this base tree, I can either make a binary tree like this, or I can either make a binary tree like this, or I can make a binary tree like this. Okay. Similarly, if you use this one as my base tree, means base tree of with number of nodes is equal to 2. If I take this one, now I can either add a left child to this or I can add a right child to this, and adding a left child or right child will increase the height of the tree by 1 because this is the leaf at maximum depth. Or I can add a left child to the root. Okay, so one possibility is this, the another possibility is this, and the another possibility is this, and these two are same. Okay, so I no need to draw this. Similarly, if I have to make a binary tree with n is equal to 4, how I will do, I will take any binary tree of, means any of this tree as a base tree and then add one more node to it. So as you can see, when n is equal to 1, you have just one binary tree or binary structures. When n is equal to 2, you have two binary structures. When n is equal to 3, you have 5 binary structures. And the formula is number of binary structures for when number of node is n is 2n cn by n plus 1. This is the number of binary structures for a given n. Okay, and if you are labeling, if you also want to label the nodes, for example, you have 3 nodes and you want to label it by a, b and c, okay, then for every structure you can label it in 3 factorial ways. So if you have 3 nodes here, okay, so if you have 3 nodes, then for every binary structure 3 factorial labelings are possible. Means you can either label it like this one as a, this one as b, this one as c, or you can do b and this one you can do c and this one you can do a. So in this manner, 6, with every labeling you get a different tree, and you will get six binary trees just for this structure, 6 binary trees just for this structure, 6 binary trees just for this structure, because with every labeling you get a different binary tree. So with n nodes, this is the number of structures. This is equal to number of binary structures. This is equal to number of binary structures. And if you want to ask that how many different binary trees possible when you have to label it also, then it will be 2n cn by n plus 1 into n factorial. I will write it here, 2n cn divided by n plus 1 into n factorial. Okay, this is the number of binary trees with number of labeled binary trees. Number of labeled binary trees. Now look at these four trees. Okay, these four trees with n is equal to 3. This is the trees with maximum height. Okay, when you want to have when a number of nodes is given to you and you want to make a tree with maximum height, then you draw a tree with as skew as possible. If you want to get maximum depth or maximum height with a given number of nodes, then what you will do is you just make sure at every level you just have one node. Okay, and if you want to have minimum depth or minimum height for a given number of nodes, you try to make it a dense tree, or you try to make it as perfect as possible, means as close to 2 to the power I nodes at every level. Okay, so here let's say if you want to have as minimum depth as possible for n is equal to 3, then at this level, at the level 1, what is the maximum number of nodes possible? That is 2 to the power 1. So you will have 2 nodes here. Means that every level is going to be filled completely. So if you want to draw a tree with minimum number of nodes, then you are supposed to give child to all of the nodes in the level. So when you can go to another level only when this level is completely filled. Okay, so for similarly you can look at here, you are supposed to give all the child to this, then only you can give child to any of the two node here. Okay, so thank you very much.